I'm Nicholas Borners of Capital Link, and I'm delighted that we're starting our second day, our first panel of the second day, with a focus on one of the most critical topics the industry is facing today: how to design the ships of the future, what types of fuels, engines, and hull and ship designs to use, and the technology going with it. So we have a panel of very high-level executives who are going to share their insight on this topic. I would like to thank Mr. Hayato Suga-san, Corporate Officer of ClassNK, for actually putting this panel together and for moderating it. So I will welcome also the panelists, but I will let Suga-san introduce them. Again, thank you to all of you for being with us, and special thanks to ClassNK for putting together and moderating the panel.
Yes. And thank you, Mr. Bornoji-san, and the kind and the warm and the openings. Hello, and everybody. I'm Hayato Suga, and ClassNK Tokyo, and I'm taking the role of the moderator of this session. And this session is just Morinoji-san said, designing ships of the future, fuels, engines, hull ship design and technologies. We have recognized that decarbonization pressure has been increased, and furthermore in future. It may change not only the ship design specification, but also the shipping itself. Under such circumstances, we are expected changes on designing ships. What should be considered into the design? What to develop the technology for this purpose? Today, we have 5 distinguished panelists from shipowner, shipbuilder, and engine manufacturers. And now I would like to welcome all panelists and ask to briefly introduce yourself. It is ready. And I would like to ask the Motoi-san first.
Okay, good morning, everyone. My name is Tatsuya Motoi. I'm an executive officer of the Kawasaki Heavy Industries. And I'm naval architect and specialized in structural design of gas carrier, LNG, and LPG carriers in Kawasaki Heavy Industries. While you may associate Kawasaki with motorcycle, we have a wide range of technology for energy and transportation equipment such as ships, aerospace, rolling stocks, distributed power generation system, precision machinery, and robots. By applying such technologies, we have been developing products that are necessary for realization of hydrogen energy supply chain, ranging from hydrogen production to transportation, storage, and utilization. I hope that today's discussion is meaningful and helpful to all participants. Thank you.
Thank you very much. Next is Ueda-san, please.
Okay. Is it?
Ueda-san, can you hear me? Maybe sound is not so good. So can I ask the Fiori-san for next?
Sure. Thank you, Suga-san. Well, my name is Marco Fiori. I've been, I'm almost at the end of this chain of shipping because I've always been running shipping companies. So I can probably see what probably will be needing and what our customers need. I've been for many years in D'Amico International Shipping. Now I have joined the last 2 years Premuda in Italy. And we are concentrating very much on tankers and dry cargo ships, but probably more with a flair for tankers, keeping on to my old habits. I've been very accustomed to doing business in Japan, so I'm very honored of being put on this panel because I think Japan still, it is one of the major participants in the shipbuilding and in the shipping industry. So I think my contribution should be more on discussing of what we need, the needs of these ships, and what we think will be useful in the future. Anyhow, thank you very much, Suga-san, and thank you, Nicholas, for having me on the panel.
Thank you very much. And next on Mr. Anderson, please.
Thank you, Mr. Suga, and thank you for the invitation here today. My name is Lars Anderson. I'm working with Wärtsilä. I've been here for some 30 years, and half of that in Asia. Actually 10 years in Japan. New building projects and customer relations, technology introduction is things that I've been working with for the most part. For example, the dual fuel engine technology introduction for LNG carriers. So I'm very happy to have the opportunity to be here today on this panel and looking forward to interesting discussions. Thank you.
Thank you very much. So next, Dr. Barbaris, please.
Good morning to all. My name is Lucas Barbaris. I'm president of Safe Bulkers. We are owners of a fleet of about 43 dry bulk vessels, and we are focusing our attention right now in the transition to greenhouse gas new regulations that will be adopted. We believe, I mean, we have done, let's say, we are always proactive in terms of environmental protection, having installed in most of our fleet ballast water treatment systems and have scrubbers. And it's a very important target right now to us, the achievement of new legislation with the greenhouse gases.
Thank you very much. And how about the Ueda-san? Can you hear me now?
I can hear you.
Yeah, please do it.
Can you hear me? Okay, okay. I'm sorry, maybe my computer is not working well. Okay, I introduce myself. My name is Jin Weather. I'm working in Mitsubishi Shipbuilding, headquartered in Yokohama in Japan, and in charge of the marine engineering department. As a member of Mitsubishi Heavy Industry Group, Mitsubishi Shipbuilding contributes to the development of marine industry through shipbuilding and shipbuilding-based marine engineering. In recent years, with an eye on the future of the ocean and ship, we have been actively engaged in activities to provide ships and related technologies and our vision of marine future streams. So today, I would like to exchange views on the future environmental technologies related to future marine future stream. Thank you very much.
Thank you very much. So now we would like to move to the actual discussion. And for easy consensus for the discussion point, I have prepared one sheet here. I will share it. Just a moment. So this is just showing our distinguished panelists, and the title was in our session. And this is just showing the situation here. And I think there are the two main viewpoints to be considered for this session. And the first one is the future change of the shipping itself, such as a new trend of the ship type, ship size, cargoes to be carried under the decarbonization pressures. The shipping capacity is expected to be continuously expanded, but on the other hand, the peak demand of cost, somebody said, has passed. Oil to be maybe in near future, gases maybe 2030, something like that. So what will happen? That is one viewpoint. And the other viewpoint is reduction of the CO2 emitted from ships directly. And this is directly linked to the new technology and the ship design. It includes the increase the ship performance efficiency by hull design, additional fittings, and the supplemental powers, etc. So change of the fuel and the engine propulsion system is also the key point. And from this point of view, I would like to ask some questions for our panelists, and then we'd like to exchange a view each other. And the first one is, how do you think about the changes for future shipping by decarbonization pressure here, and such as the new energy trends, trading in lieu of the conventional fossil cargoes? Also, what is the market demand on this? So I would like to have the first comment, and from the Ueda-san, Mitsubishi Heavy Industries.
Yes, thank you very much. I see the electric power demand increases with the progress of electrification, but the electric power becomes carbon-free using renewable energies. In the field of transportation, electric motors will be promoted for a car, and hybrid system may be adapted for trucks. And the carbon-free fuel will be adapted for ships and aircraft. In the industrial sectors, the shift to carbon-free fuel is also progressing. In the steel industry, which is expecting large-scale carbon-free fuel demands. However, some other industry sectors, such as petrochemicals, may face challenges. As was the case in the fossil era, regional differences in cost of power generation and in competitiveness of industry will also arise in the renewable energy era. Then the demand for large-scale energy storage and long-distance energy transportation will be required. And in parallel with the expansion of the renewable energy, it will be necessary to use the CO2 capture in order to maintain the economic efficiency, I think. For example, in thermal power plants, the use of hydrogen or ammonia in addition to the conventional fuel will significantly reduce the CO2 emission, but some partial conventional fuel needed for keeping economic efficiency. Then the CO2 needed to be captured at the power station for a while. So during the energy transition period, power generation and industry will be necessary to capture the generated CO2, as well as use of the new energy sources. So the energy transport flows begin from the primary energy source, such as renewable energy, and natural gas, and so on. The hydrogen is produced from renewable energy and synthetic methane, synthetic ammonia, and other mediums will be stored and transported to downstream side. An energy value chain will be created on the case by case of the consumers, such as gas turbine case, fuel cell case, and direct use in the steel industry case, and so on. Hydrogen, which is obtained as a primary energy, will be transformed to the other media for transportation and handlings. But if technology is established, hydrogen long distance transportation is also possible, I think. The CO2 is not an energy source. However, on the backside of the energy transportation, the CO2 transportation for storage or recycling will be considered in near future, I think.
Thank you very much, Ueda-san. And how about Mr. Fiori? Do you have any opinion, comment here?
Yeah, thank you very much, Mr. Suga. My opinion is that there are several things I would like to say. Number one is that is this change in for the future? For sure it is. I don't think that is something that we can escape. It is now, it's not only a fashion, this is something that we'll have to learn how to live, and we have to adapt. So number one is something that's there existing. Number two, I think that all whatever we are doing today, it is very much on a transition phase. Why transition? Because I think it's not sure yet, as we have heard and we're going to hear, there is yet a clear answer on what is going to be the future of propulsion on ships. However, this has to be matched with the fact that ships are needed. So during this transition phase, we'll have to find ways of maintaining a number of ships which will be supplying the energy and the raw material which are needed in the world for this during this period of transition. So I think that all of this considered, I think for sure we're going to be looking at different ways of proceeding. I think there's been some very clear indications. Because also you must understand that we are very much pressured, and talking on a ship operational side, we are pressured very much now by our customers who really want an efficient, and especially now they want also somebody with a low carbon imprint in the world. So we are also very much pushed by our customer base. So I think we'll have to find some things for this period of transition. And the final result, I think it is still very much a matter of debate, but I think inevitably we're going to see this change. And I think that the clearest market-wise indication of this is that a lot of traditional participants in the new building arena, they have slowed very much orders at shipyards because nobody is very sure about what is going to be the future of the propulsion. So I think that for sure now we need to have some clear indication for what we're going to do during this period of transition, and as fast as possible, we really need to understand what's going to be the future, because otherwise there's going to be created this huge backlog between what our customer wants, what the world wants, and we need to provide also to all of these participants some clear indications. So for sure, there's going to be a big change in demand, and the carbon footprint has to be lowered. Now, I think it's a matter of debate how we're going to do it.
Okay, thank you very much, and I agree. Very many uncertainties there. So we will carefully expect in the future. And how about Dr. Barbaris? Do you have any comments here?
Yes, of course. The question is about the changes in shipping due to decarbonization pressure. And of course, we all can understand that new legislations arise and are adopted, like carbon intensity indexes, like and in the levels of IMO. And we will see taxation schemes adopted gradually, which probably could become more expensive later. So what should we expect is lesser operational efficiency and less energy efficiency of older vessels, and less and more consuming vessels compared to the most recent and most energy efficient vessels that have been produced more recently, let's say phase 1, phase 2, or phase 3 vessels that will be produced after 2025. So we believe that we will have a world in the following years where we will have, let's say, various tiers of vessels that need to compete, and some will compete and will be more expensive. As we go along, of course, the question arises in relation to vessel designs. So we need to see the response of the, let's say, universities in terms of fuels and yards in terms of designs that will produce more efficient vessels. I cannot comment right now. I mean, as a company, we have ordered vessels that correspond to emissions of phase 3 vessels, but only few yards produce such vessels. So I think that yards need to invest. The shipping community need to continue the research in order to have reliable solutions in the future, because we can see that we may have certain solutions in 2023 onwards, even with slower steaming, but we will not have the required solutions for 2030 or further on. So there is a big change in the industry. As I say this, I mean, as a company, we transport we're a dry bulk cargo company, pure dry bulk cargo. So we transport dry bulk. I say all this from our point of view. Thank you.
Okay, thank you very much. So in the, I think the tier 3 complying vessel is still strong power to be chosen, and also the some of the expected future to be considered carefully. And so I would like to move to the next question related to the set market. And what is expected for new energy carrier, and such as the design concept and the specification and any other? So from for this kind of question, I'd like to ask Mr. Motoi to have the comment.
Okay, thank you, Suga-san. As for the energy resources, in the field of stationary power generation, the use of ammonia and hydrogen is investigated as zero carbon fuel. Accordingly, needs for transportation of new energy, such as ammonia and hydrogen, will be gradually increased. Renewable energy, such as wind power and solar, is candidate for a new energy. But I focus on energy media which can be stored and conserved. Well, there are pros and cons of usage of ammonia and hydrogen. Ammonia can be transported by LPG carriers, and storage tanks can be designed by existing technology. But safety precaution for human and marine environment in case of leakage is required due to its toxicity. Well, as for hydrogen transportation, there are some alternatives: liquefied hydrogen, ammonia, and chemical hydride. I think liquefied hydrogen seems to be quite reasonable because additional energy of reforming is not required, and it can be used to fuel cell or internal combustion engines directly. The point of hydrogen carrier is cargo containment system. Liquefied hydrogen is cryogenic, minus 253 degrees Celsius. It is 90 degrees Celsius lower than LNG. And hydrogen is easy to evaporate. The choice of cargo tank material and development of high-performance insulation system is required. And also, design concept of hydrogen carrier is quite different from LNG carrier because liquefied hydrogen is 7 times lighter than LNG. For new energy carriers, a cargo of ammonia or hydrogen would be used as marine fuel. Ammonia engine is now under development, and certain manufacturers announced delivery in mid-2020s. Therefore, design concept would not be changed, but cargo volume will be increased as market demand. And there exists some propulsion system for hydrogen fuel. Electric propulsion system using fuel cell is demonstrated in small vessels. For small vessels, fuel storage volume is quite small, and such system will be implemented in practical use within a decade. Some projects are ongoing. For widespread of hydrogen use as marine fuel, development of large power propulsion system and large fuel storage tank is expected, I think. Thank you.
Yes, thank you very much. And I have just wondered such a very specific in the specification of the hydrogen, liquefied hydrogen carriers. And how about Mr. Fiori? Do you have any comment for here?
Well, I think that what's going to be requested on the shipping world is going to be, as I said before, efficiency and a low carbon footprint. But then all of this has to be, Suga-san, has to be matched with the fact that you cannot stop transporting energy, because energy is still going to be needed. So has to be found something that is viable and also easy to transport. Now, if it's going to be hydrogen or ammonia, I'm not sure which, or other things, I'm not sure which system, but anyhow, has to be found something that is easy to transport, and it's also easy to load on board of ships and also to discharge, and has to be also a safe material. If you put all of this together, I think that it is a very difficult question, because putting all these things together, moving from an energy based on hydrocarbons, moving to some new things, also has to be seen all the supply chain. Because I'm sure that ammonia, you're talking a lot of green ammonia, gray ammonia, you know, all of these things. If for producing them, you're emitting a high carbon footprint, we're back to square one. So you're not emitting it on the ships, but you're emitting a carbon gas from during the manufacturing. So I think that's why the process is going to be very long and also very, very uncertain. So I think what has to be done by the regulators, the shipyards, and everybody is to make this process the shortest possible and also the most certain possible, because I think markets always hate uncertainty. And living in this kind of uncertainty is very difficult for us who will have to transport these materials, but especially for all the shipbuilding industry, which is huge, the engine manufacturing industry, which is huge. So I think we need certainties and kind of fast, because I think if living in a world of uncertainties, all of this is going to slow down, and that's not good for anybody, for the consumer, for the manufacturers, and for the people who have to transport it.
Yeah, okay, I agree. Thank you very much, Fiori-san. Yes, so we have then the next 2-3 questions that prepared. So I would like to move to the next question. And what is the preferable, reliable design concept to increase in the fuel efficiency? So I would like to ask a comment for Mr. Anderson.
Thank you, Mr. Suga. Yeah, I think that we can achieve a lot if we would start paying more attention to the actual operating profile of a vessel when the design and the machinery is decided. Because as we all know today, the design speed and the scantling draft, they are like the reference points. But in reality, ships are operating extensively at much lower speeds, and sometimes I think perhaps even never at the design point that they were built for. So also, if you look at the statistics for the past 10 years or so, the average vessel speeds have come down more than 15%. And we all know that if you operate the engine at MCR about 30% or so, the fuel economy is very poor. Propeller is not laid out for that either, and you know, compared to the design point, which has been perhaps 75% or so. So there's a big gap, and I think that this, you know, this is going to change. You know, with Poseidon principles and the Sea Cargo Charter coming into the picture, CO2 emissions is going to be measured against the deadweight ton, cargo carried, and the voyage distance. So these things with fuel efficiency measured at this sort of old school design point, it's going to be much less relevant. And I think that as a consequence, this machinery selection process is going to be become much more data driven. I think that's a very good thing. Also, when it comes to new buildings, in order to extend or let's say to maximize that compliance runway with these decarbonization trajectories for the Poseidon and the Sea Cargo, I think that these decarbonization upgrades that are available, they should also be considered. We all know there's no one size fits all when it comes to energy saving devices, and there's lots of different alternatives to choose from. But I think it's really important to do a value mapping for new building to determine if there is something in there that could make sense. And not just look at these traditional payback calculations, how much does it cost and when does it pay back. You have to account also for the future cash flows that you can earn if you safeguard your charter utilization. You can look at what it meaning has for your net asset value of the vessel in the future. Monetizing this carbon reduction that you have available via Poseidon in terms of access to banks, preferred lending versus mezzanine finance and so on. Not to mention carbon credit regimes. So yeah, I think that's my comments.
Okay, understand. Thank you very much for your valuable comments. And how about Ueda-san? Do you have any comment for this?
Well,
Yes. Thank you, Suga-san. I'm agree with the Anderson's opinion that the data-driven will be important for the future design. Yeah, I think that the way for the increase the fuel efficiency is based on the some classical technique like the air lubrication system or ladder valve or propeller cap or valve shapes, down shape, and for the wind deflector or propeller optimization and so on. But these are still that these devices is usually designed on the point of the design conditions. But in recent years, the efforts have been began to remotely and directly measure the fuel efficiency in the actual condition and operational conditions. So, and it is conceivable to improve the ways of the operation or feedbacks from the ship's design. And I think that additionally, the smart use of the energy on board, such as a hybrid battery system and the combination with the engines is also for the good technologies for improve the efficiencies.
Yes, thank you very much, and you were very comment.
Suga-san, can I make a comment on what Mr. Anderson said? I totally agree with him, but I want also to add one thing, that the main key word in all of this has to be shared effort, because I've been in this business for many years, and often we find also the final user of the ships is normally the charterers, and then there is the general public. Has to be realized that this can be done, but it's going to entail added cost for the whole chain, and therefore also added cost in the transportation, because this has been always the problem, that to owners and operators have always been requested more modern ships, more efficient ships. But then when the market is not when the market is very strong as at the top, often charterers prefer lower efficiency ships but cheaper ships. So I think has to be a common shared goal that everybody has to accept that this transition is going to cost money down the line. And then also the final consumer has to be accepted, because otherwise it doesn't make sense that, you know, shipping is a very expensive business. We do projects for 15 years, 20 years of amortization, and changing the rules and imposing us to have more expensive to operate vessels has to be accepted from everybody that these costs have to be shared. And this, I think, is very, very important, because often the owners and operators have been left with bearing the cost and always big difficulty in pushing the added cost to the second part of the chain, which is charters and final consumers. So I think this has to be very much, I go back to what I said before, has to be regulated, has to be implemented in regulations in which everybody has to be chipping in this effort, because we cannot be left alone to just take on our shoulders this kind of effort.
I agree.
Thank you very much, Mr. Fiori. And we have the very valuable good comment from the shipping and the business and also the operation point of view. And now I would like to move to the next question. What is expected changes of fuels? That is one of the key points for this session with ship design concept, and including the engine propulsion technology improvement. So for this, and I would like to ask Mr. Anderson and giving the comment together with some of the very specific development of the engine propulsion systems as well.
Thanks, Mr. Suga. Okay. Well, I'd like to start by saying that the only available green bunkers that we have today, that's biodiesel or biogas. Okay. And I think that's the starting point when we start looking at what we're going to do for a new building. Should we go with the liquid or should we go with the gas? And I'd like to point out that the engine technology is not a showstopper. Doesn't matter if it's biodiesel or biogas, we can run on that, both of them. We can run on synthetic fuels if they are available, and we also have installations on methanol. By the way, methanol and biodiesel will require a catalyst to deal with the NOx, so that has to be accounted for. But I think engine technology is not the showstopper. It's more about, where will you bunker? What are the required bunkering volumes, and tank sizes, and how many tanks do you need to have in your new building? So if you start with low sulfur fuel oil, for example, and you plan perhaps later that you want to blend in biodiesel to reduce your CO2 emissions, you may need to have a separate tank for that biodiesel. Not necessarily, but could be. So it has to be analyzed. If you would like to go with methanol, that requires 3 times the bunker volume for the same operating range for your vessel. And it needs special coating, and it needs a separate fuel supply system. So that needs to be considered. LNG, in Wärtsilä we like LNG, it's no secret. And if you go with LNG, you have more freedom because you don't need to have a separate tank then later on if you want to start blending in bio LNG or synthetic LNG. So, it's all methane, so you can put it in the same tank. It doesn't matter. Also, if you go with LNG, you have the possibility then later on, if they become available, to blend in ammonia or hydrogen, because the engine can blend that. You can blend that in with the gas. They will of course require separate tanks, and the safety aspects and systems are going to be very interesting to see how they'll turn out. Those more exotic sort of energy carrying fuels, they're going to have I think they're going to have a big impact on vessel designs. Bunkering volumes, ammonia is 1.5 times LNG. Hydrogen would be 2.6 times LNG. I also mentioned already about hydrogen being very cryogenic, minus 253. I don't know how that's going to work. So it's a long way to go with those. We're going to start testing ammonia this year on engines, and we're going to be offering them soon enough. I'm confident that's going to be working fine with the engine technology. I don't see a problem. It's basically like burning a gas. There's discussions about what these NO2 emissions will mean, or laughing gas. And they can be dealt with a catalyst, but it's some things we still have to test. But then the supply of ammonia, that's an entirely different discussion, I think. Where is it going to come from?
Sorry, just to make on a practical point of view. I heard many times you mentioned the word, Mr. Anderson, you mentioned the word catalyst. We also have to be careful that ships cannot become a chemical plant, where because the conditions, you operate far away in the middle of the world, in the middle of the sea. So, if you start loading catalyst and this and that, so it cannot be all on the shipping industry, that burden of finding this. So we go back that the choice is very complicated. Then the second comment is, if we go on LNG, there is one word that causes me always a little bit of anguish, which is the methane slippage, that you're reducing the CO2 emission, but then you're emitting methane, which is just as bad for the atmosphere as it is CO2. So we should not go in a system that we move to LNG, and then in 5 years we say, no, this is not working. We're emitting methane, we have to change again. We cannot change every 5 years ships that have a lifespan of 15 years, because financially the equation does not hold. So I go back, that has to be found one system, and then we have to stick to it, because we cannot continue this change continuously from one system to another. And I think there has to be very much clarity and very much of research and study, which would bring that this transition period in which there's going to be slow steaming, low sulfur gas with slow steaming, less emission, has to be there for a certain period of time, because I think there's going to be needed a certain period of time for getting at the final solution. And the final solution implies something that's going to be holding what's good for the planet, what's good for us, but also what is good and efficient for the shipping industry, because otherwise it doesn't hold the whole thing.
If I may add something here, the shipping industry has suffered the last years from a number of changes and experimentations, and the one big change was the change of fuels for sulfur oxide emissions in 2020, and now we are discussing a new change, which of course, and we have not developed a final solution for the new fuel. So we don't know exactly what will be the new fuel, but we are discussing for that. So I think that if we need to be, first of all, we need to be pragmatic. So we need to understand whether we want to have, which will be the next fuel. The next fuel needs some a phase of transition, which should be quite lengthy, because whatever you name, it has been named like ammonia or hydrogen, etc. You need to have a global network. And this will not happen from one day to the other. So, for example, either we continue with what we have today, which is a reduction and energy efficiency measures in existing ships and new designs that will reduce, let's say, or they will increase they will reduce the CO2 emissions by 30% or even something more. If we want to be pragmatic and we want another step, we need to target the methane slip and go, let's say, for the next 10 to 20 years with LNG fuel until we produce the new fuels that are required. Of course, the LNG cannot change in one day, as Mr. Fiori said. It has to stay for, let's say, 5-10 years. And I believe strongly that the only available fuel right now in the market is LNG, if we don't discuss about the others. So the industry, for example, could focus on methane slip control and produce a new generation. Of course, such ships would be much more expensive, and the cost should be shared also with the charterers and the operators of this market. Thank you.
I totally agree with you, and you said something that is very true. We're always changing target. A few years ago was sulfur emission, and it went to low sulfur fuel. Now it is CO2. We have also to decide what is the final goal and stick to it, because it can't continue like that every 2-3 years, okay, this is solved, let's move to something else. This cannot continue for us. I think it's making our life too difficult. And what has not to be forgotten is that we're not doing a job that is totally optional. We're doing a job that the world needs. So what we have to accept is also has to be accepted by the whole world as some kind of cost or some kind of thing for continuing developing and maintaining our level of life or civilization. Then if we change also that paradigm, then that's another story. But if we want to live the way we've been living, I think we have all to decide together what's going to be the final thing.
Yes, thank you, Mr. Fiori. And unfortunately, it is time to close it. So I have many things to ask our panelists, but time is consuming and very much. And so I would like to say then thank you very much for the audience and also the great panelists here today. And I would like to hand over this to the secretariat side.
Well, I would like to
Thank you very much.
Sorry, go ahead.
No, thank you to everybody. Thank you, Nicholas.
Marco and Suga-san, thank you for being a very skillful moderator. Thank you to everybody for a particularly interesting discussion. And actually, exactly here we had the shipyards, the engine manufacturers, the ship owners, the class society, really a very comprehensive and compact agenda. Thank you very, very much to all of you. Thank you.
Thank you very much.
Thank you to all. Thank you, Nicholas.
Thank you very much.
Thank you. Bye-bye.
Thank you.
Bye.